Hello class, this is Mr. Liebforth along with Mr. Cote. We're going to be talking about area of a quadrilateral with perpendicular diagonals. Here we go. So probably the first figure that you think of when we talk about perpendicular diagonals is a kite. What we have here is the two different diagonals. We have one right here and right here. And they create right angles, 90-degree angles. They're perpendicular to each other. And this is just your kind of standard kite that you had when you were a kid. You know, here you are flying your kite, a little bit of hair and stuff with a big smile on your face. There's a breeze coming through, but kites have perpendicular diagonals. Now, kites aren't the only figures with perpendicular diagonals. If you remember, squares and rhombuses are examples of kites, and so squares also have, we'll see if it'll let me draw it on here, squares also have diagonals that are perpendicular. And a rhombus, remember a parallelogram with four congruent sides, also has perpendicular diagonals. And so when we say it, you can think about a kite, but squares and rhombuses are other specific examples as well. We also have kind of a general figure with perpendicular diagonals. If you look at this one, I mean, if it's a kite, you'd expect these two sides to be equal to each other, and then these two sides to be equal, two disjoint pairs of consecutive sides being congruent. But in this figure, that's not the case. And so you still see that we have perpendicular diagonals, and we'll just call this a general figure. Same rule will apply for this one. So I've mentioned these words a few times. I just want to make sure I highlight it. We're trying to find the area of any quadrilateral with perpendicular diagonals. The diagonals connect one vertex of a quadrilateral to the opposite vertex. So in this picture, it's the blue diagonal and the red diagonal. And I thought, who better than Curious George to introduce the formula for the first time? The area of a figure like this is 1/2 diagonal 1 times diagonal 2. And so that's how we can find out the area of a figure, a quadrilateral with perpendicular diagonals. And I'll give you a couple seconds to get that down. So your area of a kite, it could be a square, it could be a rhombus, and it could just be kind of that general figure is 1/2 diagonal 1 times diagonal 2. So you would want to make sure that you have that down in your notes. All right, well, why does this formula work? So you have the formula 1/2 diagonal 1 times diagonal 2. Why does this work? So let's start with the standard kite. You have this side congruent to this side, and then you have another pair congruent as well. This is kind of our standard kite. You have, coming across the figure, you have diagonal 1. And then what I did was I split diagonal 2 into two different parts. My hope is that you remember a formula for area of a triangle from an earlier class, which is 1/2 base times height. And so what I'm going to do is I'm going to try to find the area of this top triangle here, which is 1/2, and it's going to be the base, which is diagonal 1, times the height, which is this perpendicular height A. And I'm going to add that to the triangle on the bottom, right here, and that's going to be 1/2 the base, which is diagonal 1, times its triangle's height, which is B. And I'm going to use an algebra rule where I'm going to factor out 1/2 and diagonal 1. And what's left from the first term, once I factor that out, is an A. And what's left from the second term after I factor that out is a B. And so the question now becomes, what is A plus B? Well, A plus B is the other diagonal. So if I called one diagonal diagonal 1, this diagonal is going to be diagonal 2. And so A plus B becomes diagonal 2. And so that's kind of a justification for the area of this kite. In this slide, I just have a basic example, kind of a straightforward example for a kite. You see the kite pictured above. We have, the traditional kite here. KT, the green diagonal, is 6, and EI, the red diagonal, is 10. And I like to kind of format my problems like this. I always write just the standard formula. This is also good for partial credit on a quiz or test. Tell me you know the formula. Here's the formula for area of a kite. 1/2 diagonal 1 times diagonal 2. In our problem, diagonal 1 is 6 units, and so I plug that in. Diagonal 2 is 10 units. I plug that in as well. And so basically I'm just filling in the blanks to the formula and then calculating it out. Remember, for area, it's in square units. It might be square centimeters, square inches, but it's 30 square units for this particular figure. So basically I just did 6 times 10 and divided by 2. Here's another problem. Find the area of a square with perimeter 40. If the perimeter is 40, that means each side is 10. And so we know in this example that the area of this is 10 squared, or 100 square units. But we also know that a square is a special type of kite. It has perpendicular diagonals. And it also is a 45, 45, 90 right triangle. So what that means is that the diagonal there is going to be 10 root 2, and the other diagonal is going to be exactly the same. And so you have 1/2 10 root 2 times 10 root 2. And so I have 10 times 10, which is 100. I still have the half out front. Root 2 times root 2 is 2. And 1/2 of 100 is 50 times 2 is 100. So that's in square units as well. And so you'll notice we get the same answer there in both cases. Here's a final problem. Now this one is a rhombus. It seems like we have 4 congruent sides. The perpendicular diagonals are there, and we're given a little bit of information here as well. It says that RB is 3, and in a rhombus you should know that the diagonals bisect each other because it's a parallelogram. RH is 5, and so that actually means all of the sides are going to be 5, and that means these are all going to be 3, 4, 5 right triangles. That's 4, this is 4. So I'm going to use my area formula that says 1/2 diagonal 1 times diagonal 2. It's going to be 1/2 diagonal 1, which is 6, and then diagonal 2, which is 8. And you can see it doesn't really matter which one you call diagonal 1, which one you call diagonal 2. So that's like 3 times 8, which is 24 square units. So in this video, we attempted to talk about the area of a quadrilateral with perpendicular diagonals. One example of that is a kite. A square is another example. A square is a special type of kite. A rhombus was the third example. A rhombus is a special type of kite as well. And we also talked a little bit about a general quadrilateral with perpendicular diagonals. The main idea was you need to be able to find the area of these figures. The area is 1/2 diagonal 1 times diagonal 2. So in a problem like this, all you really need to find are the, wait for it, perpendicular diagonals. I hope we were able to get a little bit of understanding. We'll try a few problems now as a class. Thank you for listening. This has been Mr. Leapforth with Mr. Cote. We'll be continuing to develop the idea of quadrilaterals with the perpendicular diagonals and their area.